Hello everyone, welcome to part 2 of chapter 20, where we'll be discussing our next component of spectrophotometers, the monochromator. So once we have generated our light, our broadband light, we need to be able to select specific wavelengths that we want for our specific molecules we're trying to measure, or whatever analyte we're trying to measure in solution. And so we do this with a monochromator, which that comes from the words monochrome, meaning a single color. We pick out a single color from a broad spectrum of colors that's generated by a lamp. And so if we want to separate out the different colors, we need a way to physically do this, to make them in different places in space, and then we can pick out the specific color that we want. So the two main things that are used to do this are prisms or diffraction gratings. Prisms are pieces of glass that are wedge-shaped. You've probably seen these or heard of these before. And the light bends inside of the prism. They work very well, but they're not as common anymore because they don't work as well as the other option, which is a diffraction grating. Diffraction gratings look something like this picture on the right over here. So we have a piece of material that has a bunch of grooves cut into it that are at a regular spacing, and we give that the letter D to indicate the distance between those grooves. And diffraction gratings are often quoted in terms of number of grooves per millimeter or something like that. And so the diffraction gratings can work either by reflecting or transmitting light, so the light can be reflected off like a mirror, or it can go through the grating and be diffracted as it goes through. Either one works, and works kind of on the same principles. We'll consider just reflection gratings here. They're more common in spectrophotometers, but either one works just fine. So the way diffraction gratings work is that we have our incident light coming in, and usually this is fixed, this angle theta. And we have light coming out that will interfere with light coming off of the other grooves. And so as the light interferes at specific angles, we'll get what's known as constructive interference. And so I have another picture here from your textbook that kind of illustrates when we're talking about light as a wave. We can think about if we have two waves going together that are in phase, meaning the peaks line up and the troughs line up. When they add together, we get a wave that's bigger. And this is constructive interference. So the color gets stronger, that particular wavelength. If our waves are slightly out of phase, we'll get a smaller signal. It'll still be at the same wavelength, but if we get something that's completely out of phase where the peaks line up with the troughs, we get destructive interference where our light will just disappear. And so a diffraction grating has, let me move myself out of the way here. A diffraction grating, the constructive interference occurs at a specific set of angles that's listed here. So for a given wavelength, there's a specific angle, an output angle, where we will get that color of light coming out. And so this depends on D, the spacing between the grooves, right? So this D that shows up here. And it also depends on the value n, which we call the diffraction order. So there are multiple angles where we can get constructive interference for a particular wavelength. And because we have periodic functions here, we have sine functions that repeat over and over again. So we get multiple different angles where we can get constructive interference, and which particular one of those is governed by this diffraction order, this n. And we'll see that n shows up in other places in some of the equations that relate to diffraction gratings, which we'll see on the next couple slides. But that's the basic idea: is we get constructive interference, right? We keep this angle theta pretty much fixed for most monochromators, and what we do is we can change the angle phi. We can change the angle that's being reflected by turning the diffraction grating. So if we have it here, we have a motor on it that can twist it so that the angle of the light coming off is a little bit different. And what we'll see is that allows us to pick a particular wavelength we want to look at.